You know that feeling, right? You're in the middle of an online game and suddenly you lag out, only to reappear across the map. Or you look at your phone and the clock is just a few seconds off from your laptop. It's what's called clock drift. It is the quiet, constant chaos of our digital lives, where all our devices are just kind of guessing what time it really is. But what if you could get rid of all that chaos for good?
Okay, so let's start with this thing. It looks like a QR code you might see on a menu, but it's so much more. This isn't just a link to some information, it literally is the information. This image from a project called the Atomic Kernel contains an entire, self-contained, and perfectly provable digital universe.
Yeah, that's the big question, isn't it? How on earth is that possible? Well, we're going to peel this thing back like an onion, and you're going to see how pure, simple math can build a digital world that's free from all the messiness we're used to.
So let's get to that first layer. At the very center of the atomic kernel, you're not going to find a physical clock, made of quartz or anything like that. No, there's something way more perfect. A clock built entirely out of mathematics. They call it the software crystal.
And this is a wild idea. The crystal doesn't think or process like a normal computer. It's more like a mathematical tuning fork. It just oscillates. It gives off this perfect, unwavering beat that is absolutely identical on any machine, anywhere in the world, forever. No drift, ever.
So where does this perfect rhythm come from? Is it just a random number they picked? Nope, it's mathematically inevitable. And it all starts with this one simple fraction.
And here's where it gets beautiful. If you divide 1 by 73, the repeating decimal part gives you this exact 8-digit sequence. The system needed an 8-step cycle, and it turns out that 73 is the smallest prime number whose reciprocal has an 8-digit period. The math itself pointed to the answer. It's not some arbitrary choice. It was inevitable. And that's what makes it so unbreakable.
Okay, and this is where that perfect clock becomes a legitimate superpower. In normal computing, if you want to know what happens at tick 1 million, you have to run all 999,999 steps before it. It's a slog. But with the atomic kernel, because the clock is just a pure mathematical formula, you can just plug in 1 million and instantly get the answer. This is called O of 1, or constant time complexity, and trust me, it changes everything.
So, if you have a perfect clock that lets you jump to any moment in time instantly, what kind of world can you build? The answer is a pretty radical one. A world that has absolutely zero memory.
Now this slide gets right to the heart of how everything connects. That O1 clock we just talked about, it's the key that unlocks this whole stateless design. I mean, think about it. Why do our computers even need memory? Well, to remember what happened in the previous moment. But if you can instantly calculate the state of the universe at any tick from scratch just using a mathematical law, you don't need to remember anything. That O1 ability makes memory totally obsolete. Here's the perfect way to picture it. You've seen it in a video game, right? Your character glitches and gets stuck inside a wall. That's a state corruption bug. The computer got confused about where you were and where you are now. In a stateless world built on this crystal, that's impossible. Your position is recalculated from an absolute mathematical truth every single frame. There is no memory that can even be corrupted.
Okay, so we've got a universe with total amnesia. So how do you do anything? How do you prove who you are or what you've done if the universe forgets everything every single instant? Well, for that, we need what's called a control plane and a little bit of cryptographic law and order.
So how does something you do, like typing a message, translate into this perfect mathematical reality? It's all about a process of purification. Every single character you type is first converted into its universal Unicode code point, its unique number. Then, that number is broken down even further into base 60 digits. Now, why all this effort? It's to create a single, completely unambiguous stream of numbers. There's no room for interpretation. This control stream is the only language the system speaks, and it turns your actions into pure, verifiable math.
Right, so how do you prove history without memory? You do it with cryptographic fingerprints called hashes. First up, you've got the SID, or system ID. Think of that as an object's DNA. It's the proof of what it fundamentally is. But the OID, the object ID, that's where the real genius is. It's a brand new hash created at every single tick of the crystal that combines three things: the perfect time, the object's unchanging SID, and the OID from the tick just before it.
And what you end up with is this unbroken chain that basically acts as memory. Even though the world itself is stateless, this cryptographic history is totally provable. To fake who you are, you would have to forge an entire chain of these cryptographic links, all the way back to the beginning of time. It's computationally, well, basically impossible.
So we've got a perfect clock, a world without memory, and cryptographic laws. But the big question remains, how do we know any of this is actually true? How do we prove that it really works?
The way the creators prove this is, frankly, just incredible. They set an almost impossibly high bar. They built the whole system's logic twice, in two languages that are fundamentally opposites: Python, which is super flexible and dynamic, the poet, and Haskell, which is mathematically rigid and strict, the accountant.
And this analogy from the source material is just perfect. They forced these two completely different ways of thinking to run the same simulation and produce bit-for-bit identical results. If they both agree, down to the last bit, you can be incredibly confident that the underlying mathematical law is solid.
And the system doesn't just run this test and say, hey, trust us, it worked. No, it packages the entire proof, the algorithms, the exact control codes, the full state of the universe, or what they call the replay artifact, into a single bundle. Everything you need to check it yourself is right there in one portable package.
And here we are, full circle, back where we started. That Aztec barcode, that's the final result. It's not a link. The raw data for that entire proof is encoded directly into the pixels of this image. It is a portable, scannable, self-contained little bundle of mathematical truth.
So after digging through all that incredible technical detail, what's the big picture here? Why on earth would anyone go through all this trouble to build a system that's so perfect and provable?
What this really is a total shift in how we think about building software. This project goes way beyond trust us, it works. It's a move toward, here is the verifiable, reproducible proof. It's about extreme accountability and giving anyone the tools to see for themselves that it's true. All right, so let's wrap up with the key takeaways. First, we saw how a simple fraction, 1/73, can create a flawless mathematical clock. Then we learned how that clock makes a stateless design possible, which just wipes out whole categories of software bugs. We saw how cryptography can build a provable history so you don't even need memory. And finally, the ultimate proof of the system isn't a promise. It's a physical artifact you can hold and check yourself.
And that leaves us with a really fascinating final thought. We've just walked through a system that's built on a foundation of absolute, verifiable mathematical truth. It really makes you wonder, in a world full of buggy software and digital uncertainty, what other systems in our lives deserve this exact level of integrity?